Hello guys, welcome back to the channel. So today we are doing Leetcode 416 partition equals subset sum, which is the problem of the day for today. So let's have a look at what the problem statement says. Given an integer array nums, okay, that's the only thing which is given to you as the input. Return true if you can partition the array into two subsets. So you need to divide the original array into two subsets with one condition. That condition is such that the sum of the elements in both subsets is equal. So for example, if you divide this particular original array, if you divide this nums into 155 and 11, then you have two subsets and the sum of both the subsets is equal to each other. If you cannot make any two subsets, then you need to return false. So it's not guaranteed that there is always that there is the possibility of always having two such equal sum subsets. So if there is, then return true. If there is not, then return false. So the very first approach, if we think about the thought process, then the very first approach which came up into my mind was this. You see, we have the array as 1, 5, it was 11 and then 5, right? So I said, okay, this seems to be like a classic two-pointer problem, and I'll sort the array into 1, 5, 5, 11, and what I'll see is something like this. So I will I will take the total sum of this array. So the total sum over here is what? It's equals to 22. Okay, and then I will start taking another sum starting from the initially it's 0, and I'll start to sort of like sum my way up as I traverse through the array. So sum becomes 1, okay, then sum becomes 6, okay, then sum becomes 11, and what you will see is, this is the important part, 11 is the half of 22, which means that at this partition you have 11 over here and you have 11 sum over here. So that is why we return true. Okay, that is the first thought which came up in my mind. So how exactly are we going to code it up? We can calculate the size of the nums. I can very easily calculate the total sum by calling the built-in accumulate function. I pass in nums.begin, nums.end as the iterators, and 0. So basically initially my total sum is 0. Then I sort the nums. What do I do next? I do something like this. So I take a current sum variable, right? What is my current sum variable? My current sum variable is this one, which is initially 0. Then what do? I need to have a loop, obviously. So I make a loop which in the worst case it's going to reach n. And what I'm doing inside of that loop is this. So exactly what I did over here. I'm going to add the current nums of I to my current sum, okay, and then I'm going to see when current sum multiplied by 2 becomes equals to total. At that point, I have found a partition such that I have half the sum over here and the other half sum over here. If I cannot do so, then I return false. But do you think that this approach is always going to, if this approach is going to pass all the test cases? It clearly does not. So if I run this code, this is 100% going to fail. And where does it fail? You see, 2, 2, 1, 1. Very carefully observe this test case. If I sort it, it becomes 1, 1, 2, 2. Now, how do I need to break it? I need to break it like this, 1, 2 and 1, 2. You see, I need to break it into 1, 2 and 1, 2. But what I'm currently doing is this. So the total sum over here is 6. The current sum, how am I calculating the current sum? Current sum becomes 1, okay, then it becomes 2, okay. Thing is, at this point it becomes 4, and it's not equals to, current sum into 2 is 8, it's not equals to the total sum. What should I have done at this point? Think about it. What should I have done at this point is, see, this is my window, I should have shrinked the window. So then this question actually becomes a combination of two pointer. and sliding window, isn't it? This question becomes a question of two pointer and sliding window. So as you know, at the point when my current sum into 2 becomes greater than total, so current sum into 2 is 8, which is greater than total, at that point you need to shrink the window. How do you shrink the window? So in order to shrink the window, you need a pointer. You see, your I is being incremented, right? So in order to shrink the window, you need a pointer over here as well. Why am I saying so? Let's see. So I take j equals 0 pointer over here and I say something like this. So while my current sum into 2, while it's greater than total sum, what I will do is I will remove nums of j. I will remove nums of j from what? From my current sum in order to decrease it. Okay, minus equal nums of j. After doing so, I will increment the j. Make sense? So you know what's going to happen is, current sum is 4. It's going to become 3 because I have removed this number from it, and then I'm going to increment the j. So what this does is it shrinks my window to these two numbers. Making sense? What I have done is I have employed the classical sliding window approach. In this scenario, as soon as this happens, you see current sum into 2 becomes equals to 6, and 6 is not greater than 6. So the while loop is going to exit, and then the current sum into 2 is going to become equals to total sum, and I'm going to return true. Initially, I was returning false because I was not employing the sliding window approach. So you see, we are intuitively building our way towards the correct solution, and even this is incorrect. Why I'm telling you is that I don't want you to memorize the solution. I want you to think about it. You see, the next test case on which this particular question fails, it lets us know a very good insight. You see, the test case is this. So if I sort it, if I write it in a sorted fashion, 2 3 4 8 9 14. Okay, 8 9 14. Just think about how you can, you know, make two subsets such that both of those subsets are have an equal sum. You see, the total of this is going to be what, 14 plus let me just use a calculator over here. So 14 plus 8 plus, sorry, 14 plus 8 plus 9 plus 2 plus 3 plus 4, the total overall is 40. Now just think about it. The sum of this part is how much? 9. Okay, so let's say I make two subsets. 40, I put 14 over here. Dekho, there is no way that I can group these, either one of these two numbers with 14. You see why? Let me show you. So if I put 8 over here, this becomes 22, and this is 100% greater than the half of 40. And I'm putting it 8 over here. So for example, if I had put 9 over here, it would have become 23. So there is no way, that I'd be able to, if I either take 8 with 14 or 9 with 14, there is no way that I'd be able to make a subset on the other side such that it has a sum which is equals to either 22 or 23. Why? Because the total sum is 40, right? So it goes without saying, obviously, that 8 and 9 are going to be over here. Why? Because we are returning true, right? So it means that there is a possibility such that you can make two equal subsets. So I need to take 8 and 9 over here. Now what remains? 2, 3 and 4. So right now 8 and 9 is 17 and this is 14. So okay, I let's say I take 3 over here, it becomes 20, and I take 2 and 4 over here, so it becomes 20 as well. These are my two subsets which have the equal sum. 8 9 3 is 20 and 14 to 4 is 20 as well. So you see, 2 actually became a part of the second subset, 3 became a part of the first subset, 4 became a part of the second subset, 8 and 9 became a part of the first subset, and 14 became a part of the second subset. There is no way that you can do this sort of a choice by using a two pointer and sliding window hybrid approach. What does this suggest? Dekho, think about it. This suggests that whenever you are at a certain index in your array, you have choices. What choice do you have? you the choice that you have is you either put it in group 1 or you put it in group 2. And what have we studied in our previous videos? What have we studied? That whenever you have choices, always and always think about recursion. Just think about it, whether you can solve it recursively or not. So you explore all the possible paths. And then, for example, if you have if you have repeating sub problems, if you have repeating states, then you can memoize your recursion as well, and then it leads to DP. So I did not directly tell you that it's a DP problem. Why? Because the intuition building, the problem solving process is what matters more, right? I could have directly told you that this was a classic dynamic programming problem. I have choices, and I can just directly put it in a DP sort of a state. But then this thought process is actually very important for you to understand. This is what makes you a better problem solver. Say it. Think, like, do not directly think of a hard approach. Think from the very simplest approach that you can solve the problem, which was a greedy one. Sort of I started thinking in terms of 2 pointers. Then I had to introduce sliding window because a test case was failing. Then this test case was failing, so I started to think in terms of dynamic programming. You see, so if I think about it, how can I solve this particular problem? So you have, let's maybe take a simpler example, which was what was the last test case that was falling. Let me have a look. The last test case which was failing was 2211. Okay, it was 2211. So I'm deliberately, yeah, chalo, let's take this test case as well. We'll not completely make the recursive tree stack for this, but then we'll make it as large as we can. So you start with 2. The first choice that you have to make is either include 2 in the first subset or include it in the second subset. So what we can do is something like this. You see, you calculate what the total sum of the sub array is. Okay, the total sum is 40. The total sum is 40. Now let's think about only one subset. The other subset, obviously, you see, if I take 2 in this subset, then that means I'm including in this one. So that is the take case. We are doing the classic take and not take approach. Okay, we are doing the classic take and not take approach. If I include this 2 in this subset, that means I'm taking it. If I do not include it in this particular subset, then it means it's a part of the other subset. So you see, I'm only deliberately trying to make one subset. The other one is automatically going to be made. So if I do not take 2, then that means it's a part of this. If I take this, then that means it's a part of this. If I do not take this, it's a part of this, so on and so forth. Okay, so what I'll do is I will explore both the ways. Right, my total sum is what? My total sum is 40. So if I take the 2, then what does my sum becomes? My sum becomes equals to 38. Right. If I do not take, it remains 40. Right. So I'll just expand the correct answer for you. So the correct answer is that we do not take this, we take this. Do not take this, take this, and do not take this. So all the not takes are actually part of the second subset. So I just expand the correct solution. I do not take the 2. What I do is I take the 1. So what? Sorry, I take the 3. So it becomes 37. Okay. If I had not taken it, it would have remained 40. Then again, I have two choices whether to take or not take 4. Right. So 4 I do not need to take. So I won't take it. If I had taken it, it would have become 33. The sum. When I take something, I'll sort of subtract it from the overall sum. If I do not take it, it remains 37. Then I'll take the 8. So if I take the 8, then it becomes 29. Okay, if I had not taken, it would have remained 37. Okay, again I have two choices, take or not take, and right now I am talking about 9. So what I'll do is I will take 9, becomes 20. If I had not taken it, it would have become 29. You see, 20 is half of 40. 20 is half of 40. So what I'll do is I'll check at this point, or not, let's not check at this point. Let's take it one step further. Now what I can do is I can either take the 14 or not take the 14. So if I take the 14, it becomes equals to 6. If I do not take the 14, it remains 20. And what you will observe at this point is that my whole array has been, explored, right? My index I is now out of bound. So that is going to be obviously our base case when our index is out of bound. So you know, we took some things, we did not take some things, and ultimately after the overall exploration, our index is out of bound. When my index is out of bound, that means that I have successfully reached the base case. At that point, what am I going to check? I'm going to check if my sum is half of the total sum. Isn't it? And there are going to be hundreds and hundreds of possibilities. If I do not memorize it, there are going to be 2 to the power n possibilities, you see. So since the array is of 6 elements, I have just shown you like two final states. I have just shown you 2 final states. Overall, you are going to have 2 to the power 6 final states if you sort of draw all of the possibilities. So just to give you an idea, this is how my recursive tree is going to look like. Now let's think about how we can code this up. Right, so you see, I need to make 2 choices at every stage, take and not take. So what I'll do is I'll first of all again calculate nums.size, calculate the total sum, and then just call a recursive function, solve 0, nums, total sum, 0. Okay, all right. And inside of that solve, what am I receiving? I'm receiving I'm receiving nums, I'm receiving total sum, which is what, 40. In this case it was 40, and I'm receiving the current sum, which I'm calculating on the go. So what's the first thing which I need to do? The first thing which I need to do is take. So when I take something, I increment the index obviously, and in the current sum initially what I could have done is I could have passed the total sum over here, and I could have subtracted the nums of I from that. But then what I'm doing over here is I'm passing a 0 and I'm adding nums of I to it. Okay, means the same thing. So when I take something, I add nums of I to current sum. If I do not take something, then the current sum remains the same. And you see, the thing is this is not, if I multiply it by 2, this does not equals 40. So I'm going to return a false from here. Why? Because I need to ultimately, from the can partition function, I need to return a boolean. So this particular if state is going to return a false, but then this particular if state is going to return a true. Now what should this if state receive? Even if just one if state returns a true, then I should receive a true over here. So that is why what I'm going to do over here is I'm going to return take or not take. So even if there is one true state, okay, so the upper state should receive a true. False or true is true. Makes sense. And then again, the only thing which is missing over here is the base case. So let me just add that over here as well. As soon as the index goes out of bound, just check that the current sum that you have, if you multiply it by 2, does it equal total sum or not? If it does, return true. If it does not, return false. And obviously what's going to happen is that this particular code is not going to pass all the test cases. Why? Because you see, your constraints are actually 200, and 2 to the power 200 is actually a very large number. So what I'll do is I'll take the DP array. I'll take a DP array. Why am I taking 201 and 20,001? Because you see, there are 2 parameters which are changing. My I is changing, and I can take the maximum value of 200. So I have to take into account that. And my current sum is changing. You see, what can be the largest value of current sum? In the worst case, every number is 100 and you have 200 numbers. So the largest value that the current sum can take is going to be 20,000. That's why I'm taking an array of 20,001, so that I have indexes from 0 to 20,000. Okay, Zabardast. Then the only thing which I need to do is memoize. So what I'll do is I'll say, before actually returning whatever your answer is, also cache it. Okay, cache it in the 2D array. So I'm going to say return, before returning, cache it. dp of I comma current sum is equals to this. Alright, similarly over here as well, I'm going to do the same thing. Sorry, before returning it, just cache it. And similarly, if before doing any processing, just check, just check. Let me tell you what this line of code means. This line of code actually, before I call the solve function, this line of code fills this 2D array with all negative ones. So every place is negative one at the very start in the initialization phase. That means that I haven't processed, I haven't finished any state. If I had finished any state, then that particular state would have had a value which is not negative one. Okay, initially every value is negative one, but then when you update a state, it takes a value which is other than negative one. So I'm going to check exactly that over here. If dp of I and current sum, if it's not equals to negative 1, then that means that you have already seen this state before. So you don't need to do all the effort all over again. You don't need to make the recursive calls or all over again. You just need to return dp of I current sum, because you have seen this state previously as well. So if we submit this code, let's see if it passes all the test cases. Okay, it does. So think about what the time complexity is going to be in this case. You see, if I was talking about the brute force approach, it would have been 2 to the power n. But then since we have memoized it, it is now only O of n. That is why our code actually passes. So keep this thing in mind as well, that why is memoization important in this particular scenario. So I hope this video was fruitful for you, and I hope that you learned how the process of problem solving actually goes. And I'll see you next time. Till then, take care.